In this program, we're going to take an in-depth look into the digestive systems of ruminants. An overview of the ruminant digestive tract anatomy, prehension, salivation, and rumination, the rumen and the reticulum, the omasum, abomasum, and lower digestive tract.
Following each section, a series of review questions will be presented. Answers are provided in the teacher's key. You may stop the program to discuss a topic or to allow more time to answer questions. Your host is Dr. Kevin R. Pond. Dr. Pond received his Bachelor of Science degree from Cornell University and both his master's and doctorate from Texas A&M University. He began his teaching career at Texas A&M and then taught for several years at North Carolina State University. He is now professor and chair for the Department of Animal Science and Food Technology at Texas Tech University. Dr. Pond has been awarded numerous teaching awards and was chosen Outstanding Young Animal Scientist in Education. Besides his teaching duties, Dr. Pond contributes to education through journal articles, reports, manuscripts, and textbook contributions and authorships. Dr. Pond is co-author of Basic Animal Nutrition and Feeding, a leading collegiate textbook for animal nutrition. Ruminants are animals that have multiple stomach compartments rather than one simple stomach. There are wide varieties of ruminant species. Common examples of ruminants are cattle, sheep, goats, and deer.
What we have in front of us here is a digestive tract from an 1,100-pound steer that was slaughtered just a few hours ago. And we have spread it out to remove some of the tissue so we can see things a little bit better from the esophagus, which would be in at the head. It's been tied off here, all the way down to the rectum, which has been tied off there. So all of this is the digestive tract in between that the steer would be using to digest and absorb the nutrients from the feed. I have the esophagus in my hand. Of course, up here at the mouth, it's been cut right at the end of the mouth. Its function is going to be to carry material down. In the case of a steer, it also brings material back up for chewing their cud. You've probably seen cows that chew their cud. Well, the esophagus has a function of going both directions. It enters into the rumen, which is this large area here that is actually filled with gas now because of the digestion that continues to go on by the bacteria that inhabit the rumen. And the other part of the tract here is the reticulum, and this area right here is attached to the rumen. The opening of the esophagus actually just goes into the junction of the reticulum and the rumen. From the reticulum, the exit from that is right about here, and it goes into this structure, which is the omasum. And if you feel it, you probably can see it, it's quite hard. From there it goes on to the true stomach, which is the abomasum, which is right here. To the abomasum, it goes into the small intestine, which I have the beginning of right here. And the small intestine goes all the way through, and you can see a very long intestines that you see here all the way through the tract, and then eventually joins in, and at the end of the small intestine, the very end, it forms a T-juncture with the cecum, which would be the appendix in humans. So we have the small intestine entering into the junction with the cecum. The rest of the material will go into the large intestine, and the large intestine follows on through here, coils, and comes out to the rectum. Not only can we study the digestive systems through dissection, we can also use newer technologies such as cannulation of the animal or use of a laparoscope. We're standing here right next to a rumen cannulated steer, and the cannula is placed on the animal right here, and what I have on my hand is the cannula. That's the physical part that is in the animal. The opening goes directly into the first stomach of the ruminant, into the rumen. And it's placed right behind the ribs, which are right here, and before the hip, which is right here. So we have a natural placement where the rumen wall comes in contact directly with the skin. We surgically place this in the animal by suturing the rumen wall to the skin and then making this opening. So we have a sealed area all the way around here that the cannula is then placed into. So this is directly looking into the rumen. Now I can put my hand into that rumen. We have removed the contents from the rumen, but I can put my hand in here, feel the structures, look at the structures, and we're going to attempt to view those with the use of a laparoscope and some other handheld cameras to get an idea of exactly what it's like in the rumen of the animal.
Prepare for questions from Section 1. Which of the following terms refers to the part of a structure closest to the belly? A. Anterior, B. Posterior, C. Ventral, D. Dorsal. Which of the following digestive structures is considered to be the true stomach in ruminants? A. Rumen, B. Reticulum, C. Omasum, D. Abomasum. What man-made physical object is placed into the side of live cattle so scientists can access the rumen to study the contents during digestion? A. Appendix, B. Rectum, C. Cannula, D. Laparoscope. Which of the following animals are considered ruminants? A. Cattle, B. Sheep, C. Deer, D. All of the above. What compartment is considered the first stomach of a ruminant? A. Rumen, B. Reticulum, C. Omasum, D. Abomasum.
The prehension of food is the way the animal will gather the food. If we talk about the organ of prehension in man, it would be our hands, because we take our food with our hands and bring it to our mouth. If we compare that to a cow, the organ of prehension in a cow is the tongue. It will take its tongue, will extend it from its mouth, wrap it around the forage or grass that it's trying to consume, bring it back into the mouth, bite it, and consume it. In the case of a sheep or a goat, it's very similar to that of a cow. They'll use their tongue, but they also use their lips. In fact, a sheep and goat have a split upper lip, and so it enables them to graze even closer than a cow would graze. When we talk about bringing the food into the mouth, then we have to have mastication occur to break down that feed. As an example of a ruminant skull, I have a skull of a deer. It's slightly smaller than that of a cow, so I can show you the structures on it much easier. All ruminants are going to have both in the front molars and real molars on both upper and lower jaw. And then in addition, we'll have in the front, we'll have incisors, which are only on the lower jaw, and a dental pad on the upper jaw. As the animal consumes its feed, it's going to grasp it with its lip and tongue in the case of cows, bring it into the mouth. It will clamp down between the upper dental pad and lower incisors, pull that forage, rip it off, and then bring it back into the mouth with the tongue and chew it with the molars and premolars. The basic structure is the same as we move from species to species. If we take a close look at the molars and premolars, you'll notice that they do not line up in that we have only one contact can occur at one side at a time. As they consume material, they would chew it on one side. When they're tired of chewing on that side, they'll rotate and be chewing on the opposite side. So as you look at an animal, you can determine which side it's chewing on, and oftentimes you can see if there's a tooth problem associated with that animal as it chews. As you take a close look, you can see that the muzzle width of a cow is much wider than that of a sheep. This will be true for a goat and also some of the other antelopes or other species we might see in a zoo. In the case of sheep and goats, notice their narrow muzzle allows them to get at material they wish to consume, whereas a cow is going to be consuming with large amounts of material that's brought in by its tongue. The lips of sheep and goats are also more mobile and are able to select particular leaves on a plant, whereas the cow will probably consume the entire plant. This size difference allows the animal to consume more selectively if it's much narrower. So in terms of selectivity of grazing, a sheep and goat are much more selective grazers compared to a cow, which consumes most anything that's brought into the mouth via the tongue. Ruminants spend the majority of their time chewing. They spend about 8 hours a day acquiring their feed and grazing, about 8 hours a day chewing their cud or ruminating, and then only 8 hours a day resting. So the majority of the day is spent in jaw movement activities. Note that there is no upper incisors at all on either one of these skulls, and there would not be on any ruminant species. While the animal is chewing, and at all times during the day, it is secreting saliva. Saliva is secreted from the parotid gland, mandibular gland, and buccal gland, and goes into the mouth and is mixed with the feed that the animal has consumed. We have fed the animal some hay. He's consumed that hay, and those are some of the particles that he's consumed. The foamy material you see is the saliva that was produced. The saliva is very important in adding moisture to the feed, allowing the feed to become softened to allow it to be swallowed, and involved with beginning of digestion. There are very few enzymes in saliva, but saliva contains a high content of water and many minerals that help aid in digestion and keeping the digestive tract healthy. Again, you can see the saliva, high mucus content, allowing the animal to swallow material it swallowed, and also in buffering the rumen. It depends on both species and size of the animal and the amount of saliva that is produced. A full-size cow will generally produce about 50 liters of saliva per day. As an animal consumes a coarse feed such as hay, it will keep it in its mouth and continue chewing until saliva has had enough opportunity to make the material soft enough to swallow. Much like when you eat a cracker, you don't swallow it until you have enough moisture to allow it to go down your esophagus. What we've cut off here is a section of the esophagus, and I want you to notice how thick it is. It's very muscular, and of course its main function is to bring material from the mouth to the reticulum and rumen, and then also backwards for rumination. So it's very, very thick, muscular type tissue, and of course an open hollow tube. Rumination is a sequence of events that allows material from the reticulum and rumen to be brought from there to the mouth. It is a reverse aspiration, and we have material coming directly up the esophagus to be chewed. And so we will see an animal ruminate, and you'll watch an animal will chew on one side for one bolus. We'll then pause, we'll swallow, bring up another bolus, and generally they'll switch to the other side. Once it arrives in the mouth, the animal will swallow the liquid material and then chew the remaining material until satisfied. It will then be swallowed and reintroduced back into the reticulum and rumen. You may ask the question, why do ruminants ruminate? It is thought that through evolution, ruminants did consume large amounts of material very quickly and then retired to a secure area where they could ruminate and re-chew what they'd consumed, thus avoiding the dangers of being caught by a predator.
Prepare for questions from Section 2. Which of the following is not present in ruminants? A. Upper incisors. B. Lower incisors. C. Dental pad. D. Premolars. How many liters of saliva can a steer produce in a day? A. 10 liters. B. 25 liters. C. 50 liters. D. 100 liters. Which of the following is not abundantly present in saliva? A. Water. B. Minerals. C. Digestive